All right, class, this is our last video on the basic rules of integration. So in this video, we're covering Rule 7 on page 74 of your note packet. And it has to do with the antiderivative of any exponential base function. So we already found the antiderivative of e to the x, right, which has a base of e. Now we're going to find the antiderivative of a to the x, okay, where a is any positive real number not equal to 1. So we're finding the antiderivative of exponential functions of any base. And for an exponential function to be an exponential function, the base a has to be positive and not equal to 1. So the antiderivative a to the x with respect to x is not just a to the x. It's a to the x times 1 over the natural log of a. So the antiderivative a to the x with respect to x is 1 over the natural log of a times a to the x plus an arbitrary constant c. So we had 3 examples on page 74. In the first example, we can find an antiderivative to the x with respect to x. Well, the base a in this case is 2. And so from our formula up here, the antiderivative to the x with respect to x is 1 over the natural log of 2 times 2 to the x plus c. Now let's jump to example 3 down here at the bottom of the board. In example 3, you got to find the antiderivative of 9 to the x with respect to x. Well, a in this case, right, is equal to 9. And so from our formula up here, the antiderivative of 9 to the x with respect to x is 1 over the natural log of 9 times 9 to the x plus c. Now let's go to example 2. You got to find the antiderivative of 3 to the x minus e to the x. So this function has 2 terms, so we can find its antiderivative term by term. And so this is equal to the antiderivative of 3 to the x minus the antiderivative of e to the x. Well, the antiderivative of 3 to the x, right, a is equal to 3. And so from our formula up here, the antiderivative of 3 to the x is 1 over the natural log of 3 times 3 to the x. And then minus the antiderivative of e to the x is e to the x. And then we add, when we're all done antidifferentiating, we add our arbitrary constant c. So the antiderivative of this function is equal to this in the rectangle.